Hi guys, good morning. Three of you are there. Okay, wait for 2 more minutes. Is it because of it's Christmas? That's why people are late. Guys, if you have your friend's number, you can text them or call them. Ask them to join soon. Okay, people, will start. Yeah, if you're wondering what is this, I was trying to correct your papers, right? And this is Abhishek's paper. Anyways, so
Sir, your voice is little low, sir.
my voice is pretty low. Is it okay
Yeah.
now?
Hi. No.
Okay. No, I was speaking a little low. That's why. Like, not everybody has joined, so I thought I'll not waste my energy now itself. Right. Okay. So guys, we have completed your ionic equilibrium, everything I completed. Right. So we just have to do a couple of problems, and then we'll move on. Right. 1 second, guys. Okay. Right. So I just want you to remember. Yeah. So I just wanted to remember a few formulas, right? So hope you remember what are the formulas you have to remember so that we can go about the problems, right? So first we'll talk about salt hydrolysis, right? So we just need to know what is the formula for acidic salts and basic salt, pH of acidic salts and pH of basic salts. So if you remember the formula for acidic salts, right? For acidic salts, pH will be 7 minus half into pKb plus log C, right? This would have been the formula, right? So this pKb is the weak basis pKb value, and this C talks about concentration of the salt, right? This is for an acidic salt, if you remember, right? Okay, so then when I go for a basic salt, right? For basic salt, pH will be equal to 7 plus half into pKa plus log C. Again, the pKa is the pKa of the weak acid. Okay, I can see is the concentration of the salt. Okay, so that's about your acidic and basic salts is pH, right? Now when I go for buffer solution, right? So buffer solution, acidic buffer, again I have two types of buffers, hope you remember, right? This stylus is actually, I don't know what exactly is the problem. Sometimes it works amazingly, sometimes it's happened like this. Anyways, acidic buffer pH, right, is what is it? Wait, it's pKa plus log of salt concentration divided by the acid concentration. Right, that is for the acidic buffers is pH. Right, now when I go for basic buffer, now we don't calculate pH, we calculate pOH. In that case, it will be pKb plus log of salt concentration divided by, here it is going to be the basis concentration, just like how you have an acidic buffer. Right, the basis concentration. So these four formulas, and yeah, and there are two more formulas. That is the hydrolysis constant. So here itself I'll write my KH will be equal to KW by KB. Same way here, KH will be KW divided by Ka. So this six formulas is what you have to remember, right? If you know this formula, I think theoretical questions will be very rare from these areas, people, right? So you'll be getting 99% only problems from this, and it's pretty simple. And I'll tell you how to understand, right? So there can be confusions when you look at a problem. There can be confusion that say whether it's coming from a salt hydrolysis problem or it's coming from a buffer solution problem. Like, how will you identify it, right? Now the key is that you know how I'm going to form an acidic or basic buffer. Can someone tell me, how do you form an acidic buffer? What you need to mix for forming an acidic buffer?
Weak acid, the salt of the weak acid.
Exactly, right? You have to use a weak acid and the salt of the weak acid. And if you look at the formula, right, you need the salt concentration as well as the acid concentration. Same way, if you go for a basic buffer, you need the salt concentration, the weak base and the salt of the weak base. Both concentrations we need, right? But if you look at salt hydrolysis, right, now you there is no way that you'll be using, say, I know that acidic salt is formed from a weak base plus a strong acid, right? But no way here you will be using your the base concentration or the acid concentration for that matter. Only the salt concentration is given, right? So in a question, right, if they give you only salt concentration, again I'm repeating, if in a question, if they give you only salt concentration, you directly go for salt hydrolysis, either acidic or basic depending on the salt, right? But in a question, if they give you both the salt concentration as well as the acid or the base concentration, two concentrations are given, that is two molarity values, one for the salt, one for the acid or the base, depending on what kind of buffer it is, then you go for buffer solutions. That is how you identify the questions, people. If you do not do this simple formula substitutions, you will not be able to get the problem right, right? So if two concentrations are given, salt as well as the acid or the base, it's buffer. If only one concentration, that is the salt concentration, is given, then you go for hydrolysis, salt hydrolysis problems. Okay, so we'll keep this in mind. Now we'll go for problems. Okay, just give me a moment. Okay, take out the question, people. Right. The question is, calculate the pH of a solution. Calculate the pH of a solution in which calculate the pH of the solution in which 0.2 m, capital M, NH4Cl, in which 0.2 m NH4Cl and 0.1 m NH3 are present. Okay, I repeat the question. calculate the pH of a solution in which 0.2 m NH4Cl and 0.1 m NH3 are present, and they have given pKb of NH3. pKb value of NH3 is 4.74. Is 4.74. Okay, now tell me which question is it? Which area? Is it from salt hydrolysis or it's from buffer? Hope you guys are there. Yeah, tell me guys whether it's buffer solution problem, or the problem which I gave you, or is it salt hydrolysis? Just now I told you, right? How do you find out whether it's a salt hydrolysis problem or a buffer solution problem? What is this? Am I on mute? No, like,
We are able to hear you, sir.
Yeah. So tell me.
Sir, is it buffer solution based?
Obviously, right? It is buffer solution. Now, how do you find it out? I told you, whenever two concentrations, one is the base or the acid concentration and the salt concentration, if both are given to you, it is going to be a buffer solution problem. Right now, you see here, I have NH4Cl, salt, NH3, base. So again, or they can even give, instead of NH3, I could have even given NH4OH because both are same. I told you how both are same, ammonia and NH4OH. If we just dissolve ammonia in water, you are actually going to get NH4OH. Anyways, right? So in this question, you see they have given 0.2 m NH4Cl and 0.1 m NH3. So they have given the base concentration as well as the salt concentration. So definitely this question is from buffer. Right. Now the next question is what kind of buffer it is. Is it basic buffer or acidic buffer?
Basic, sir.
Definitely, right? Ammonia is a weak base, NH4Cl is the salt of the weak base, right? So this question is from basic buffer solution. And what buffer? It is basic buffer. Depending on what salt and what base is given to me, I'll be able to predict that. Right. Now go for it. Tell me the answer. Now they're asking you pH, guys. And if you look at the formula here, right, for basic buffer, we have calculated only pOH. Now you know how to calculate pH from pOH, right? The sum of pH and pOH is always equal to 40, right? So use this formula, find pOH first, and then from that you calculate pH. pKb is also given to you, right? pKb of ammonia, the weak base, right, is given to us as 4.74. Now use the formula, just the formula substitution.
So I have a doubt in the formula.
Yeah.
So in this thing you put salt by acid.
Salt, first one is salt by acid, second one is salt by base concentration.
So it like divided, sir.
Divided. Log of whole thing. Log of whole thing, salt by base concentration.
Okay, sir.
Yeah. Right. So it's how to substitute the formulas here, people. Right. So if I substitute, only calculation will be remaining, right? So pOH of this particular buffer, right, will be 4.74. Right, that's what's given us the pKb value of NH4OH or NH3 plus log of, now the salt concentration, salt here is NH4Cl, right? Ammonium chloride is the salt. So 0.2 divided by the base concentration, which is 0.1. So 0.1 by 0.2 will become log of 2, right? So you know what is log 2 value? Log 2 value is 0.3010. So it will be 4.74 plus log 2. That is 0.2 by 0.1 will become log 2, right? So log 2 value is 0.3010, right? So that add this, and this is my POH, right? So when I want to calculate pH, right? So pH will be 14 minus 4.74 minus 0.3010. Minus 3, 0. Wait, like this is plus and plus. So if I calculate the pH, it will be 14 minus 4.74 minus 0.3010. Right? Easy question. Just a formula substitution here. But the only thing is you have to understand which part the question is from. That if you understand, you're done.
Okay,
any answer?
question, what was the concentration on the base, sir?
0.1. I told you 0.1 mNH3.
Okay,
Yes.
sir.
Right. The question is given 0.2 m NH4Cl and 0.1 m NH3. Okay, can we go to the next question? Okay, the next question, people.
Yes, sir.
Yeah. Find the amount of, once again, let's see whether some other good question is there. Oh, no issues. Let's do this. Okay. Find the amount of NH4 twice SO4 ammonium sulfate, right? Find the amount of NH4 ammonium sulfate, NH4 twice SO4, right? Which must be added to 500 ml of 0.2 m NH4OH solution, 0.2 m NH4OH solution to yield a solution of pH, 9.26. Okay, I'll repeat the question. Find the amount of ammonium sulfate NH4 twice SO4 which must be added to 500 ml of 0.2 m NH4OH solution to yield a solution of pH 9.26. Okay, and they've given one more thing. pKb value of ammonium hydroxide NH4OH. pKb of NH4OH is 4.74. Right? pKb of NH4OH is 4.74. Now, when I say amount, I'm talking about number of moles. You can even write, find the number of moles of ammonium sulfate. That is also, that's actually the better question. Find the number of moles of ammonium sulfate, which must be added to 500 ml of 0.2 m NH4OH solution to yield a pH of 9.26. And the pKb value of NH4OH is 4.74. Okay, right? Now
Sir,
again,
doubt,
it's,
sir.
yeah.
In the question given that 500 ml of 0.2 m of what, sir?
NH4OH.
Okay.
Yeah. Right. So again, you see there is a salt. The salt is ammonium sulfate, And again, there is a base. The base is NH4OH. They are mixing them both. So definitely they are trying to prepare a buffer solution, right? And now I know what is the pH I need, right? I know what is the pH I need. So now what they want is the number of moles of ammonium sulfate, right? Now again, it's just the formula substitution. If you know just what is the formula for molarity, that is number of moles by volume, then the problem is done. Just one more formula you have to remember. Right. If I do.
Sir, can you zoom out your screen a little bit, sir? It is so.
Oh, wait. Yes, tell me. Hello. If you, yes, tell me, Kanna.
Zoom out your screen, sir. It is too zoomed, sir. Right part is not visible at all, sir.
No, there is nothing to be visible here. I just wrote the formulas. Or if you want, I can stop sharing the screen. That I can do. You don't have to look at the laptop or phone, whatever you're using. You just do the problem.
Okay, sir.
Yeah. Or like if you want to zoom out, yeah, I can do that. Zooming out. Right. So again, a buffer solution, again, basic buffer. So at the same formula, POH formula. This formula. Right. So, but they're given pH, right? So you have to take 14 minus 4.7. What is the value? 9.26. Okay. So I have to take 14 minus 9.26 is equal to, now why 14 minus 9.26? Because they're given pH value, not POH value, right? So 14 minus 9.26 pKb they have given as 4.74 plus log of, I don't know the salt concentration, right? But I know the volume. Volume is going to be similar, 500 ml. The total solution's volume is 500 ml. So I'll just put number of moles of ammonium sulfate, NH4 twice SO4 divided by volume. Volume is 500 ml. Guys, hope you understand what am I doing here, right? I'm just doing the number of molarity equation. Molarity is equal to number of moles by volume. Okay, now divided by the concentration. The concentration of the base. The concentration of the base is given to be 0.2 m. NH4OH concentration is 0.2 m. That's it. So what you need is this. The number of moles of ammonium sulfate is what is needed. Everything else is given to us. Okay, actually we can put 1,000 also because you're using it in ml. Here the volume is in ml, so you multiply by 1,000 also. Right, that also you can do. Okay, so again a simple formula substitution. Okay, you don't have to worry about the log calculations, people, because anyways you'll be given log books. Okay, anti-log, log, everything you know, right? But I can do this problem even without a log book because I know some log values. I told you how handy it will be if you know at least from log 1 to log 10. Log 1 is 0, log 10 is 1. Between that, if you I told you how to remember the values also, if you can remember, right? So I can do this problem, but if you also remember the values, you can also do the problem without any log books. Yeah, tell it.
So I have a doubt. How did you find out 9.26 is pH? It's not given in the question, right?
Yes, they have given this thing, no, to yield the solution of pH of 9.26.
It could be even POH, right?
They have given, right, specifically they have mentioned pH to yield the solution of pH 9.26. They have mentioned,
sir.
Yes, yes, they have mentioned. They have mentioned.
Okay, sir.
Right. Generally, they in the questions they will not give POH value, very rarely, but not at least in JE they might give, but for your CBSE levels, no, they are not going to give POH. They will always give only PH. Okay, so I think hope everybody understood what kind of how to do the problem. It's pretty simple. Again, a formula substitution, except that you need to know what is the formula for number of molarity. Okay. Right. Now, next question, guys. Okay. The next question. Hydrolysis constant of NH4 plus ion. Hydrolysis constant of NH4 plus ion is 5.55 into 10 to the power minus 10. Right? The hydrolysis constant of NH4 plus ion is 5.55 into 10 to the power minus 10. Right. Now they're asking, what is the ionization constant? What is the ionization constant of NH4 plus ion? What is the ionization constant of NH4 plus ion? Okay, they're giving you the hydrolysis constant for that particular ion. See, when I say NH4 plus ion, hydrolysis constant, basically I'm talking about a salt. Okay, NH4Cl or NH4, ammonium sulfate, something like that, right? Now they're asking, what is the ionization constant of NH4 plus? Now, before you go on to the question, now tell me the ionization constant which I'm talking about, is it Ka or Kb? Tell me. I'm asking you what is the ionization constant of NH4 plus ion. Am I asking you Ka value or Kb value? Tell me.
K is KB,
Yes.
sir, actually.
Okay, first one is correct. Ka. Okay, answer is Ka. Now tell me, why is it Ka? How do you find this? Whether it's Ka or Kb?
It's NH4 plus, right?
Okay.
So the plus indicates that it's deficient of a neutron. So we had to use OH minus.
Okay. So the thing is, people, right? So ammonia is a base, correct? Right. So obviously for NH3, if they have given you, right, NH3 definitely I would have gone for Kb value because that's a base, right? But NH4 plus, is it not the conjugate acid of the base? Is it not after adding H plus? Or say if I take NH4OH also, if I've given NH4OH, again I go for Kb value because it's a base, right? After removing OH minus, what is remaining? NH4 plus. Or say if I take ammonia, after adding H plus, what is remaining? NH4 plus. So obviously NH4 plus is the conjugate acid of the base NH3, or say for the matter NH4OH. So definitely I have to use Ka value for NH4 plus because it's the conjugate acid of the base. That's where you go for Ka value. Okay, right. Now, I think you'll be able to easily do this. But anyways, I will do a little, I'll help you in this. Right. So first tell me, guys, what kind of salt are we talking about? Obviously, we're talking about salts, right? Are we talking about an acidic salt or a basic salt?
Acidic, sir.
Sorry.
Is it acidic salt?
Yes, it is an acidic salt. Why? Because when I have ammonia, or say when I have NH4O, that's a weak base. Definitely, I would have added with a strong acid to form a acidic salt. Strong acid plus weak base. Correct, right? So if you can remember, what is the formula for KH? There, KH was KW. Now it's a basic salt, so definitely I'll be finding the KB value, guys. Please remember, I always use only the weak terms here, right? We will not use anything. Strong acids Ka value is not going to be useful here, right? So this is my acidic salt, right? And this is my hydrolysis constant, Kw. We know the value, 10 power minus 14. Kb value we can find out. Correct, right? This is for Kb of ammonia actually, or NH4OH for that matter, right? This is Kb of ammonia or NH4OH. But what they're asking is not this. This value is not they're asking. They're asking your Ka value of NH4 plus. How will you do it? Tell me. From the Kb value of ammonia, how will you calculate the Ka value of NH4 plus? I told you there is a thing which you can do. When you have an acid-base conjugate pair, I gave you a formula. What was the formula? I told you that formula will work specifically only for acid-base conjugate pair. What was the formula?
The pH formula, sir.
No, not pH formula. We even did problems on that. Let me see.
C alpha.
No. Anybody wants to try? You can even put in the chat box, people, if you remember anything. There was a formula for an acid-base conjugate pair. That is an acid and a conjugate base, or a base and its conjugate acid. There is a formula connecting your Ka and Kb values of the conjugate acid-base pair. What was that? Okay, so nobody remembers. I'll tell you the formula. The formula is, once again, yeah. So the formula is Ka into Kb is equal to Kw. Hope you remember this, guys.
It's
Right?
Ka plus Kb, right?
No, it's Ka into Kb, not plus. Pka plus Pkb is equal to Pkw. When I take log on both sides, then it will become plus. Right? So Ka into Kb is equal to Kw, and this will work on and only for an acid-base conjugate pair. Right? So that's what we're using here, isn't it? So hydrolysis constant is given. I know the Kb value, but what they want here, the Ka value is for Ka of NH4 plus. If it's ammonia, the base is ammonia, right? The Ka values for NH4 plus, the Kb values for NH4OH or ammonia for that matter. What is wrong? Okay, this is for NH4OH. This is for Kb values for ammonia. So what you're finding here is the Kb value for ammonia. Okay, so I think I can directly substitute here. Is it not? So like KH will be Kw divided by, now in the place of Kb, I can write Kb is what? Kb is equal to Kw by Ka. Correct, right? So if I bring this at the top, so it will become Kw into Ka divided by Kw. So Kw gets cancelled. So whatever is the hydrolysis constant, that is the value of the Ka. As simple as that. There is actually no calculations required. Yes, right? So you understand, right? All the entire this chapter is full of formulas. You just have to remember the formulas. That's it. Okay, pretty simple problem. Hydrolysis constant is given. This is the acidic salt, so it's Kw by Kb. They are asking you what is the Ka of the conjugate acid, right? So from this, you'll be getting the Kb value for the base. And from that, I can use this formula, Ka into Kb is equal to Kw, which works only for conjugate acid base pair. So to get the Ka value, very simple, right? So guys, one last question and we will wind up for today. Any questions from this? Hope everybody understood. Right. Okay. Your question now. Take down the question. Right. Find the pH. Find the pH of 0.01 m. Find the pH of 0.01 m calcium acetate solution. Calcium acetate solution. Okay, and they have given the pKa value. They have given the pKa value of CH3COOH, acetic acid. Okay, pKa value of acetic acid is 4.74. Okay, they're asking, again, I'll repeat the question, guys. What is the pH of 0.01 m calcium acetate solution given that the pKa value of CH3COOH is 4.74? Right. Okay. Now, which area this question is from? Which area this question is from? From salt hydrolysis or from buffer?
Buffer, sir.
Why do you say that it's from buffer? I told you, how do you find out? Do not look at the pKbs, Kas, Kbs, all these things. You don't look at it. You just look at the molarity values. What did I tell you? You just look at the concentrations. How many concentrations are given here?
2, sir.
How 2 concentration? 0.01 m calcium acetate. Is there anything else given in the question? Did I tell you that 0.1 m of CH3COOH is also there? No. I just told you that there is just 0.01 m of calcium acetate. That's a salt. Calcium acetate, CH3COOH twice, Ca, calcium acetate. Right. So this question is from salt hydrolysis people. Right? I told you if only salt concentration is given, go for salt hydrolysis. If both salt and the acid or the base, depending on what type of buffer is it, then it will be a buffer solution problem. Now, in this case, this is a salt hydrolysis problem. I think you can understand how is it. They have given only one concentration, that to the salt concentration. Very, very simple. So go for the formula. Just find the pH. This is what kind of salt? Acidic salt or basic salt? Calcium acetate. Okay, let me ask you this question. For forming calcium acetate, what and all you need to mix? Obviously, to salt, you have to mix the acid and the base. What is the acid? What is the base? For calcium acetate. Okay.
Acetic acid is the base acid,
What?
sir.
Acetic acid is the acid. Okay. What is the base?
Calcium hydroxide.
That's it, right? Yes. So it's calcium hydroxide is a strong base, right? And acetic acid is a weak acid. So what type of salt is it?
Basic salt, sir.
That's it. So guys, this is how you do it. Like from the basics, right? First, you need to understand whether it's what kind of question, whether it's from buffer or from your salt hydrolysis. Obviously, you will look at the number of concentration values given. Right now, we decided it's a what is that salt hydrolysis problem. Now, the next question is whether you find out whether it's going to be an acidic salt or a basic salt. Now, the salt dip, I told you nobody will tell you in the question whether it's going to be acidic or basic salt. You need to know it. Right now, you understand that there's going to be calcium acetate. So obviously, what would have been the base? What would have been the acid? The acid would have been acetic acid, CH3COOH, right? And the base would have been calcium hydroxide, CaOH twice, right? So CaOH twice is a strong base, CH3COOH is a weak acid. So definitely, this is going to be a basic salt, right? And everything else is given to you. Just substitute in the equation. pH of a basic salt will be 7 plus half into pKa plus log C. Right? So if I just pH will be 7 plus half into pKa. pKa value is given as 4.74 for the acid plus log of the concentration of the salt, log C. C represents concentration of the salt, right? So it's going to be log of 0.1. 0.01. That's it, right? So now if you want to simplify this log of 0.01, you can write it as log of 10 to the power minus 2, right? Now, how can I write this? Now, you know how the log works with powers, right? So I can write it as this again, and I can write it as I can write it as minus 2 log 10. Is it not? Hope you remember the powers can be gotten to the sides, right? So here the power is minus 2. Right, so minus 2 log 10 value is 1. 1 into minus 2 will become minus 2. Right, so log of 0.01 is actually minus 2. That's it. So 4.74 minus 2 will become 2.74. 2.74 divided by 2 will become 1.37. Okay, so 1.37 plus 7 will become 8.37. The answer is, if you calculate, would be 8.37. Right? A basic salt, obviously you expect the pH to be greater than 7. Yes, you are getting it greater than 7. Right? So that's the formula substitution, and you have to know how to substitute. And the most important thing is finding which question is it from. And next thing is, if you find which question is it, whether it's acidic buffer or basic buffer, or acidic salt or basic salt, that two things, if you do properly, rest all is just going to be formula substitution. Okay, and I would really advise you to solve your NCERT book back issues. Like, you can, I don't know whether you realize it, right? There are a good number of questions in your test, both your chemical bonding test as well as your gaseous state test. There were a good number of questions from your NCERT book back. Not only here, even in your school exam, even if you go to your annual exam, even if you go for your 12th board exams, right? There will be good number of questions, at least 2-3 questions, 4 questions, even sometimes having seen 5 questions coming from your NCERT book back exercises. Okay, so please do solve it. I don't know how many of you have the habit of solving it, but please do solve it. Okay, right, guys, any questions?
Questions, sir.
Okay, so fine then. So Merry Christmas to all of you. We'll wind up today, right? We'll meet on Monday, right? Thank you, guys.
Thank you, sir. Wish you the same.
Yeah.
Thank you, sir.
Okay.